first thanks to all the organizers for inviting my wife and me here to Vilnius. This is our first time touring through the Baltics, Tallinn last week, Riga next week, so it was really nice to be able to come to this part of the world, even if a taxi did try to kill me the other night. Here we are. So this morning, Vite has asked me to give an introduction to Agile software development, and I decided that I wanted to do something a little bit different. I didn't want to just say, you know, here's Scrum, and here are the practices of Scrum, and here's extreme programming, and here are the practices of extreme programming, and do a whole bunch of explanation that way. Instead, what I'd like to do is talk a little bit about some of the ideas behind Agile software development that led us to, or led other people, I wasn't involved, led other people towards creating some of the principles and practices and values in Agile software development. And we started a tradition at Agile Eastern Europe in Kiev, where every time one of the keynote speakers takes a drink of water, you're supposed to applaud. So let's do that. But just remember that that tradition does not apply when Jürgen is speaking. So welcome to an unusual introduction to Agile. And I think probably the most sensible place to start, the one that we're most familiar with, is this document. So how many people have already read this document before? How many of you have actually read the rest of this document? There's the nice 12 principles, all that stuff. So the story goes, I wasn't there, that a little over 10 years ago, a bunch of people who were arguing about how to call what they did in common came together in Salt Lake City, Utah, in the US, and they wrote this. And probably the most interesting thing to know about this document is where the word Agile came from. As I understand it, the only reason why we're calling this Agile software development is because nobody in the room wanted to call themselves lightweights. And that was the original idea, was to talk about this as lightweight software development. One of the earliest comments or sort of catchphrases of extreme programming was, what's the least we can do and still make great software? How can we figure out what we can eliminate? And that turns out to be a pretty big theme in all the things that we do oriented around Agile software development. We know that eliminating waste is a big part of what we do. This is an idea that we've adopted from Toyota Production System, perhaps not as faithfully as we should have, but there it is. And so you've seen this before, I don't need to read it to you. We know that the focus, in fact, what I really liked about Agile software development when I first started was the emphasis on people. When I grew up and I was learning to program computers, I liked computers because they were easy to understand, not like people. And, you know, when I was 14, 15, 16 years old and no one wanted to talk to me, at least I could use my computers. And it was really surprising for me to find out that by the time I was 26, 27 years old and had worked for 5 years as a programmer, that I would start to buy all kinds of books on psychology, sales, that goes more about the human side of software development. In fact, I grew up outside Toronto, and I used to be part of the Agile Toronto user group. And somebody named Brian Hall, who I haven't heard from in about 8 years, but who was one of the early people in that user group, said, if I got to choose, I would call it humane programming. Because this is a way of working that remembers that people are involved and treats them, I think, as good people. Now, it's not just, you know, a bunch of talk about, let's say, abstract concepts. It's not just about, oh, people are the most important thing, and so let's just make people feel comfortable and happy and they'll build great software. There is part of that. But I think for me the big thing is that Agile software development favors evidence over theory. It's a very empirical approach to software development. We prefer to turn arguments into discussions about facts. And that's why we do things like, instead of guessing when a project will be done, we have some rough idea of when we hope it will be done. But as we go, we start building the project, we start building the product, we run the project, and we use the information that we gather about how quickly we're going to project the performance of the entire project. Instead of hoping that we can wave some magic wand that will turn the programmers and the testers and the business analysts into people capable of reaching the date that we invented 4 months ago. And so to me, this is really what sets, one of the things that sets Agile software development apart from other approaches is that we really rely on evidence instead of hopes and dreams. Or I should say, projections. Now there are a bunch of very concrete principles involved in Agile software development. This is one of my favorites. I actually just learned this last week. I was at Agile Prague, and Chris Matz, who has written a lot and talked a lot about bringing real options into Agile software development, and is sort of a well-known name in that part of the community, talked about Agile software development for business analysts. And this was the big message that he had: hunt for value. In other words, one of the things that we focus on in Agile software development is how do we find the value in what we're doing. It can be the value in what we're delivering, it can be the value in how we're doing things, it can be the value in how we work together. But this is a big part of it, and I'll talk a little bit more about value in detail in just a moment. Now, one of the other basic principles that we use is release frequently. Our goal is to try to get feedback from real users, real customers, as soon and perhaps as often as we can, with the goal of being able to use that information to make adjustments to the project as we go. This is one of the things that allows us to have a better chance to build something that's fit for use, something that will help generate more value. Usually that means more profit. And releasing frequently is one of the ways that we get more information from ourselves, from the business, from the environment, from the market, about whether we're on the right track and should we do more of this, less of that. So that means that we have to ship something. We can't sit and build up a whole bunch of software and hope that we get these features right and be afraid to give that to somebody. One of the really big differences in the Agile and iterative in general, the iterative software culture, is just ship something. Don't worry if it's incomplete. Don't worry if it doesn't do everything that your customer wants. Now, of course, there are some cases where we need to be more sensitive, but I think that in general, I think we treat a lot of our products as though they are more fragile than they really are. I think that if you look to what companies like Google tend to do with their software products, every 3 weeks I open up Google Docs and there's something new. And so releasing frequently isn't just a way to get feedback, but it's also a way for us to kind of, I suppose, take our products a bit less seriously in the sense, not in the sense that they're not important, but that we don't make that importance bigger than it really is. In some cases, our software is just something that's designed to help people. It's not going to save lives. It's not going to achieve world peace. If you're writing that software, I think that's great. But I know I never have. And so one of the things I think that Agile software teaches us to do is to stop being afraid to ship something. Stop being afraid to ship the wrong thing. Stop being afraid to ship something that doesn't fit right. Now, this does not mean that we ship crap. What we ship works. It might be incomplete. It might not be exactly what the customer, the users, or the business wanted or needed. But that's part of how we learn. So rather than trying to ship, rather than putting a constraint that forces us to make decisions about whether the system has enough quality to put in the hands of a user, we decide to test everything and get feedback as to whether what we built works. And what we ship is stuff that works, but perhaps isn't as powerful as it could be. I find it much easier to build a product up in small pieces by making sure that each piece that we build really works. And so we test everything. And we don't just test our code, we don't just test our design, we test our understanding of the business. We test our understanding of the requirements. We test our interactions with each other. We have frequent retrospectives that give us an opportunity to answer the question, are we working well together? What do we need to improve? And so testing is built into almost every aspect of a project, or even of a business, when we use Agile methods. And of course, one of the most important is this one. No more silos. By this I mean, we all work together. Now that doesn't mean that we build a kibbutz somewhere and everyone just, walks around barefoot and nobody does any real work. But it is important for business people and technical people especially to work together. Not to treat programming and testing as a completely separate activity from market research and sales. And I'm reminded of a conference about 3 years ago in Orlando in the US, where Mary was speaking, and one of the things that she said there really stuck with me. We had spent a long time in the early 2000s trying to figure out how to make the business more comfortable coming into the room with programmers and testers and working with them. And so for years and years we had this idea of how do we help bring the business into the software development? How do we bring the business into software development? And she said, no, I think we have that backwards. How do we bring the programmers and the testers into the business? And so one of the things that goes beyond running projects that I think is part of Agile software development, I know that I have become much more of an entrepreneur. I've become someone who is at least slightly financially literate. I can read a profit and loss statement. I can read a balance sheet. I understand about basic financial projections. I know what net present value means. And that's nothing, I'm no genius. I just reached a point where in order to be more effective at delivering what the business needs, I needed to be able to speak more of the business's language. And this doesn't have to be related or limited to sort of the scary idea of doing business. I mean, some of you in the room who are programmers probably don't want to run a business. That's why you work for somebody else. Well, remember, 10 years ago, I didn't want to know anything about people. So first of all, keep in mind that things change. But it doesn't necessarily have to be quite that strong a change. Eric Evans wrote this wonderful book called Domain-Driven Design. I don't know how many people in the room have read it, programmers especially, Domain-Driven Design. Now, the central message of domain-driven design, as I recall it, is that if we have a common language that the business people and the technical people can use together, and that language is used both in writing code and writing tests, as well as writing marketing research documents and sales projections and specifications, then that makes our ability to deliver a good product even higher. So he talked about the term ubiquitous language, meaning the language we use everywhere. And this is just another example of a concrete practice that we use in Agile software development designed to tear down the silos, tear down the ivory towers, whichever phrase you prefer. So those are some of the sort of high-level ideas that are an important part of Agile software development. Let's look at a few more details now. Let's see. Where am I going? Let's start here. So I had talked earlier about a couple of the key principles related to the value of software. And about 5 years ago, I was teaching some courses with a company called Object Mentor in the US. I'm Canadian, by the way. I just thought I would mention that. And they had this interesting slide in the middle of their test-driven development course called The 2 Values of Software, and I thought it was quite neat. And I was thinking more and more and talking with other people, and I added a 3rd value of software, and I want to talk about those 3 briefly. So the first value of software, I think, is fairly straightforward. We see value in software in the features, right? The features are sort of the basic currency of business value that we talk about between business people and technical people. Why? Because features, generally speaking, are what we sell, and that's how we earn money. So the first value of software is the very obvious one that I think everyone can agree on. And when we talk about business value, often this is what we mean. The more features we have that are better suited to our customers' or our users' needs, the more valuable our software is. And that's where often we derive a lot of our value. The bad news is that if we stop here, then we can get into a whole bunch of trouble. So there are other forms of value in software that we need to look at. And one of them is the design. Now again, because we have at least 120 programmers in the room and another few dozen testers and so on, I imagine that a lot of you are here because you want to learn more about design. And I want to talk a little bit about the impact that design has on the value of software. So the short version is this. The simpler the design is, the less it costs to add more features. So perhaps you've heard before of the principles of the elements of simple design. Kent Beck wrote about these years ago. The short version is you want to pass all the tests, you want to remove duplication, you want to improve clarity, and then if there's stuff left over that you can remove, please remove it. And these four simple elements, or these four elements of design are enough to help us build designs that are simple. Now, what does simple mean in this context? Really all simple means is instead of the cost of adding features over time going like this, which is fairly common in other projects, we want the cost of features to look a little bit more like this. If we can manage it even better, how about something a little more like this? The idea is that the marginal cost of a feature, which is the cost of the next feature, we want to keep that, if not low, then at least predictable. Now, I'm sure that a bunch of you have had the experience, either as the programmer or as the project manager, of being in a room discussing estimates for a piece of work, having someone say, yes, that'll take 3 days. And everyone's happy, you leave the meeting room, and then when the programmer decides to go and actually try to do the work, they open up the code base and kind of look inside and go, well, 3 weeks. How does this happen? Well, this happens because the state of the design is such that adding features is actually more difficult than we expect. And one of the things that I've learned over the years, and this is more of a conjecture on my part than it is established, generally accepted fact. So warning, this is my opinion. I believe the problem is that the state of the cost of the design dominates the cost of features for most projects most of the time. Now this comes from a concept that Fred Brooks wrote about in his very famous essay, No Silver Bullet. He talked about 2 kinds of complication in software. And Jürgen has taught me to call it complication, not complexity, because believe me, there's no emergent intelligence involved. So he talks about essential complication and accidental complication. Essential complication is the amount of complication in software for which the problem is responsible. It's the part of the software that's complicated because the problem or the domain is complicated. There's a big difference between writing software that does online auctions and writing software that audits tax returns. Right? If you're writing software in the second category, the problem is much more complicated, and so the software will be much more complicated. That's the essential complexity. Sorry, complication. I'm still learning. Then there's accidental complication. And the short version of that is accidental complication is the complication we add because we're not very good at our jobs. It's all the stuff that we do because we don't know how to do things any simpler. It's the code that we write because we know we're going to need it in 6 months. It's the 25 weeks that we spend building a backlog of 2 years of work, even though we're never going to do the bottom 85%. It's the time that we spend learning all our features or specifying all our features in detail before we hand them over to someone to build. So all these contribute to accidental complication. And I'm going to talk specifically just about the accidental complication in code. That's the stuff that we write because we think we're going to need it later, because we don't know how to make it simpler, because we're afraid that if we write less, it looks too easy. All right? Don't forget that programmers love an intellectual challenge, whether we have it or not. Guess what, folks? There's not a lot of intellectual challenge in a shopping cart. And that does not mean that you have to make it more complicated. So just a little bit of math to wake you up in the morning. So the cost of a feature, I think, depends on both the accidental and the essential complication. And I'm really not sure, but I'm pretty sure that if we just take the cost from the accidental part and we combine it somehow with the cost from the essential part, then we get roughly the cost of the feature. Now, for the mathematicians in the room, I drew the plus sign with a circle around it. I'm not saying that we actually add these things together, but it's something like addition. And my graduate professor in computer science would refer to this as false formalism. That's when you use symbols to mean something that you're not being very strict about. So I apologize to him for that, not like he's watching. Now, there's something very curious in the way that we're taught to estimate the cost of features that tries to ignore an important part of this. Now, if you've read books on, early books especially, on Scrum, extreme programming, then you know how we're taught to estimate work. You take all the tasks that need to be done, and you sort of group them by similar difficulty, similar complexity, similar similar sizes, using the very well calibrated measuring device called your gut. And you can't see because I'm sitting down, but my gut is very well calibrated. And so when we do this, we do things like this feature looks like it's about as much, has as much weird stuff in it as that feature, so probably they're similar cost. There's one problem with this approach. Remember that essential complication is the part that comes from the difficulty of the problem, and that accidental complication comes from everything else that we do. The problem is that the way that we are taught to estimate tasks assumes that this part isn't there. And guess what? On most projects, this part is huge. On most projects that I get the chance to work with, especially ones that have been around for a long time, the cost from the accidental complication is much higher than the cost from the difficulty of the problem. And if you're not sure if that's true for you, then remember the last time you said it would take 3 days, and it turned out to take 3 weeks. So how do we solve this problem? Well, it seems to me that if we could try to drive accidental complication down, if we could make this lower, then this would be closer to the truth. Now, of course, we can't make accidental complication 0 because we're not perfect. But there's a really simple practice that we use in Agile software development that helps us get fairly close. I'm not going to go into the details of how test-driven development works. You can put that into Google and find out for yourself. But there are 2 important steps in test-driven development that help us with this problem. One of the first things you do in test-driven development is you write a test that will fail because you haven't built that part of the system yet. And you want to see it fail to make sure that it fails the way you think it should. And then the rule says, write as little code as you can to make the test pass. So we can interpret this step as a way to try to avoid accidental complication in the first place, by writing less code to solve the same problem. You know you're going to need more later, but later isn't now. All you need to do is pass the current test, and if returning 12 is enough to pass the current test, then do that. So this step helps us try to avoid accidental complication by encouraging us to write less code. And in general, all of the things being the same, less code, fewer problems. Now, after the test passes, and of course we take a nice breath and relax, the next step is to refactor, to improve the structure of the code without changing the way it behaves. This is the essence of evolutionary design. This step is designed to remove any accidental complication that got in during the first step, because we're not perfect people. And so in the sort of top of the cycle, we have a step that helps us avoid accidental complication. At the bottom of the cycle, we have a step that helps us remove whatever accidental complication came in. So that's 2 steps designed to make the cost of the feature closer to the difficulty of the feature. And so this is why I like to say Scrum can't work without XP. That was actually funnier than you gave it credit for. Big fights between Scrum and XP. Should XP be part of Scrum? Blah, blah, blah. Do we do Scrum with XP? Without? Oh, I don't like those XP guys. They have too many rules. Oh, I don't like those Scrum guys. They don't have enough rules. Okay, now you have the back context to find that funny. So let's try that again. This is why I like to say Scrum can't work without XP. All kidding aside, this is one of the reasons why test-driven development, I think, has become an important part of the way we build software, whether we say we're doing extreme programming or not. And there's one practice that has made it through to the mainstream, at least of Agilists, of people interested in Agile software development, it's test-driven development. And I think part of it is just because we say it's a good idea. But if you want a better answer than that, without test-driven development, I don't think your estimates will ever really help you. That's just me. That's also why I don't estimate, but that's a different question altogether. So that's about design. Our goal is, in this case, is to reduce the cost of new features, and that helps us add more value. What this does is this adds our capacity to continue to add more features. So if features are the things that we sell to people, then keeping the design simple is a way for us to increase our capacity to deliver features. Seems pretty reasonable to me. The third value of software, at least the one that so those were the 2 that Object Mentor taught me, and I thank them very much for showing that to me. I think that's very neat. This is the third value of software, the one that I propose to add to their list. And it's a specific kind of feedback. I mean, we know that feedback in general, feedback is one of the 5 values of XP. It is a cornerstone of kind of what makes us Agile people different from those horrible waterfall people. That was a joke too, by the way. I love anyone who does waterfall. In fact, the one thing about waterfall people don't realize is iterative development is just waterfall with better organized iterations. Right? Read page 4 of the paper. There are arrows from every phase back to every other phase. Royce did not say, do it all in a row. He said it would be nice if we could do them all in a row, but unfortunately it never works. So the specific kind of feedback that I'm talking about is related to the one magic phrase that you should want your customer to say as often as possible. That's not what I wanted. This phrase is music to my ears. Why? Because it tells me that, first of all, it tells me that we tried to ship something. Because they can't say that's not what I wanted if there's nothing to compare to. And as soon as I hear that's not what I wanted, that's always followed by, change these 3 things and it'll be perfect. Now this takes advantage of a fairly well-known psychological phenomenon related to the way we describe things. So if right now I asked one of you to describe your house, just describe your house. My guess is that you wouldn't be able to describe much in the beginning because you have absolutely no idea which details matter to me. What am I interested in about your house? My house, I mean, if I were to describe my house thoroughly, it would probably take 2 hours and 10,000 words because my house is a pretty complicated place. Do you want to know about the composition of the house? Do you want to know how big it is? Do you want to know what color it is? Do you want to know when it was built? Do you want to know what's in it? Do you want to know how well it works? Do you want to know, can you tell me why water keeps pooling in my basement? there's a bunch of different things to talk about my house. So if I just ask you to describe your house, you don't know where to begin. So one of three things will happen. One possibility is that you'll say, my house is a big building in this city, and it's 1,000 square feet, and it's nice. You'll under-specify a little bit. You'll tell me a few things that might be interesting only at random. The other possibility is that you will give me the 10,000-word description of your house that includes every detail that I never ever wanted to know. The third possibility is that you'll just sit there. I don't know. So wouldn't it be nicer if we had some way of taking advantage of the way the brain works to help get an answer closer to something useful? It turns out that the airlines have this figured out, strangely enough. So how many here have how many here have flown and the airline has lost their luggage? What did they do? So you go to the lost and found. By the way, I love that in Europe they call them lost and found. Has anyone ever found anything there? Although I guess that's better than in Canada and the US where they call it the delayed baggage section. So when you go to the lost and found, and eventually you get to the front of the line, and eventually you get to sit down with a nice airline representative, and the first thing they do after they calm you down a little bit, they don't ask you, describe your bag. They hand you a chart with a bunch of pictures of suitcases, and they say, which one is closest to yours? And you point. And they write down little code 29. Okay, their bag is closest to number 29. And then the next question is, how is yours different? So then you say, well, the handle is bigger. I've tied a red bow around it so that it's easier to see. It's red, not black. And the wheels are broken from the last time you lost my bags. Notice how quickly someone you've never met is able to get important details from you in a situation where you're usually very agitated, feeling a lot of stress, probably feeling a lot of anger and frustration. And in probably 30 seconds, they've got from you the most important details they need to be able to locate your suitcase, something that's important to you. So I call this the lost luggage trick. Don't go to the customer and ask, so what would you like? Because they have no idea what to tell you. This is where we get that silly idea that my customers don't know what they want. I'm the programmer. No, let me say that again. I'm the architect. I know what my customers want. I've been doing this job for 15 years, and I know the business better than any of them. No, you don't. And even if you did, it ain't your money. So I call it the lost luggage trick. If we give something, if we put something in the hands of a real user, a real customer, whoever needs to give us that feedback, so that they can say, that's not quite what I wanted, change this, change that, or that was not what I meant at all. Change this, change that, or we have to try again. I would rather hear that's not what I wanted after 3 weeks than after 2 years. What this allows us to do is to avoid building the wrong thing. So those are the three values of software. We have the features themselves, which of course are valuable because we ship them, and that's the main way we get cash. Keeping the design simple, which makes it easier for us to build more features and more features, or at least stop us from building fewer and fewer and fewer, which is usually what happens. That's the point where the CTO comes in and says, let's do it again in Python. And we won't make the same mistakes this time. No. So there's keeping the design simple to keep our capacity high so we can keep building more features. And then there's getting feedback, getting customers, users to say, that's not what I wanted, or that's not what I meant, or, oh my God, are you kidding? So that we know that we're building only the stuff that will actually help them. So those are the values of software. And this, I think, is an important part of what informs the way that we deliver products. Not just the way that we write code, but the way that we deliver products to customers. So now I'd like to talk a little bit about the power of short cycles. So this is part of an article that you can read at any time you like, but I'm going to give you the slightly abbreviated version. And for the people in the room who have much more knowledge and experience about systems thinking and lean and Toyota production system than I have, feel free to correct me afterward. Don't make me look stupid now, please. But here's the basic idea the way I understand it. Somewhere in the middle of a complicated process, oops, that's a little too big. Somewhere in the middle of a complicated process, we have an activity followed by another activity. And there's a problem. The problem is that when we start doing the second activity, we realize that we need to redo part of the first activity, and we're really not sure how much of it we need to do, and we're really not sure how many iterations we need to go through before we decide good enough and continue on. Now, because the number of iterations through this loop is unpredictable, because the amount of rework is unpredictable, the throughput through this part of the system is unpredictable. And no matter what managers, vice presidents, or executives might tell you, if you can't give them fast, at least give them predictable. That way they can plan. We can always figure out how to go faster later. So most of the time when someone bugs you that you're going too slow, it's more that your performance is like this, and they have no idea what they're going to get from you from week to week. So how can we improve the throughput through this part of the system? Apparently, if we do a little bit of the second process or activity first, and then do a little bit of the first activity, because of course that helps us with the feedback loop problem. And if we do this in short cycles, or small batches, whichever of those you prefer, then on average, for most activities, for most people, most of the time, the throughput through this part of the system will be higher than if we do it the other way. There is still rework, but the rework is planned, it's more predictable, and anyone who's done some analysis on algorithms will know what I mean when I say that this is more optimal. The best case might not be as good, but the worst case is much better. And so it turns out that we can apply this idea to our good friend, the single pass waterfall. So in the middle of the single pass waterfall, which we all recognize, right? Gather requirements, analyze the domain, design the system, write the code, do the testing, and then deploy into production and maintain it. And as Royce said, it would be really nice if projects worked this way. Sadly, they don't. Well, what if we tried to do it this way? I know it would be crazy for anyone to actually try it, but let's assume that they did. So we have coding followed by testing in the middle of our process. I don't know about you, but occasionally, when people start testing my code, I have to change my code. They find these really stupid things called bugs. In fact, I don't like to call them bugs anymore. I like to call them what they really are. That deserved applause, so I wanted to make sure I got some. I think that we're all old enough now that we can refer to these as mistakes instead of bugs. I know the original bug was literally a bug that flew into a piece of equipment. We don't have that problem much anymore. So when we make mistakes as programmers writing code and testers find those mistakes, then we have to change the code. And we don't know how much code we'll have to change, and we don't know how many times we'll have to go through this loop. Sound familiar? I hope so. Well, if our information from systems thinking, queuing theory, Toyota production system, wherever it comes from, I know it comes from one of those really smart places. Maybe what we should do is a little bit of testing, followed by a little bit of coding, followed by a little bit of testing, followed by a little bit of coding, and do this in short cycles. And when we do this, we call this test-first programming. Test-first programming was simply the art of writing the test first, in part so that we know what we're trying to do, and in part so that we know when to stop. When the test passes, stop writing code. That's what helps keep the design a little simple. Now, test-first programming was the very first of these extreme programming practices to really gain some traction, to really become known in the community. But it turns out we can do a little bit better, because over here a little bit earlier in the process, we have this pesky design. So we have these really smart people who sit in really, really tall chairs, who think about design all day, and then tell us, go build it. Well, I don't know about you, but I can remember, especially when I used to work at IBM and we had this system set in place, there'd be all kinds of cases I could remember where I'd make a bunch of design decisions and then I'd start trying to do test-first programming, and I'd realize that the design that I had imagined was hard to test, or it had to change in some way. You know, the details in this part of the diagram didn't match the details in that part of the diagram. And so not only did I have to change my ideas about the design, but of course I went back and I updated the design diagram. Don't we all? Come on, guys, that was funny. All right. So sometimes if we make too many design decisions up front, when we try to write code and we try to test it, it's hard to test. So if we apply this idea one more time, I know the programmers in the room are starting to dig the recursion. I think that's, we write a little test, then we write a little bit of code, then we find ways to improve the design. And what we do is do this in short cycles, and we call this, by this time I'm sure you can guess, test-driven development. Test-driven development is essentially test-first programming as a pull system for design. The idea is that instead of trying to figure out every detail up front, we figure out just enough details to get started, usually 2, maybe 3, and then we start writing code to test our ideas. So when people in my classes ask me, you know, who tests the tests, we test the tests, because we look at the tests and say, if I had to use code that looked like that, if I had to write software that used that code, would I be happy? And if the answer is yes, great, and if not, time to improve the design. And there are a bunch of little tips and tricks that we use to try to improve the design, but the bottom line is that our goal is to have the throughput of well-designed software go up. And so we can apply the same concept one more time. Yes, that's what we needed 6 months ago when you wrote the document, but the market has changed since then. Or, yes, that's what you wrote 6 months ago because that's how well you understood the business, but your understanding has changed. And so when we actually try to build it, you say, that's not what I wanted. Remember, we like that. Well, it seems to me that we should be able to apply the idea one more time. Are you getting bored yet? Yeah. Yes, thank you. I appreciate the honesty. Write a little test, write a little bit of code, improve the design, and then use what you learn about the business, about the product, about the domain, to make new decisions about what we're going to build next. And we do this in short cycles, and that's called behavior-driven development. In fact, behavior-driven development can be loosely thought of as test-driven development cycle as a pull system for features. So instead of a bunch of very smart people figuring everything out and then telling us to go build it and hoping we do it correctly, what we get instead is this much closer collaboration between technical people and business people. And the business people say, I have a great idea. And between the business and the technical people, they sit down and figure out what that good idea means. We use techniques like specification by example. In fact, just talking in examples is a huge improvement. Asking business people to talk concretely about what it is that they're trying to build, combined with the lost luggage technique of, do you mean this? Do you mean this? Do you mean this? Goes a long way to exploring and understanding what it is that we're trying to build. So we do a little bit of that, we figure out what we're trying to build, and then we try to build it. And then on the way back, we say, here's what we built. And they say, yeah, looks good, or not what I wanted, please change it. And then they give us the next little bit of thing to build. And over time, when we do this really well, we actually reach the point that Mary was talking about in her talk a few years ago, where the technical people really start to understand the business, not in some I understand the domain way, but more starting to understand real business objectives. They start to understand strategy. They start to think more like it's their money instead of someone else's money that they're playing with. And that's really where we take the huge leap from being just programmers to being part of a team that's delivering value. Chris Matz talks about feature injection. I don't fully understand what he means by it, but again, the short version is using test-driven development as a pull system for features. Now, of course, we have one more part of this. There's the deploy and maintain part. I won't bother drawing the diagram, but I think you can probably see that if we deploy the empty application first and see if that actually works. In fact, that's a really good test. If you want to know if you want to know what problems you might need to solve in your company, try deploying a new project with no features. And just see how long that takes. Sometimes it takes months and requires pages and pages of paperwork. But imagine if we deployed the empty application. Dimitri is just starting to cry now because he realizes that he's heard this before. What if we deployed something, wrote a test, wrote a little bit of code, made sure the design was simple, made sure we understood what we were building, and then deployed it? And what if we did that in short cycles? The throughput should be higher, so we should be able to ship more features per unit time, which, by the way, is what we wanted to do. And we call that continuous deployment, or continuous delivery. So here is how we can take one really simple idea, just the power of short cycles to both reduce and make rework more predictable, and use that as a way to increase our ability to deliver features. And when we do test-driven development, we know we're keeping the design simple, so we know our capacity to build features has gone up. And when we do behavior-driven development, which includes this feedback cycle with customers and users, we know that we do a better job of building stuff that people actually want. And so this is really, for me, again, one of the fundamental aspects of Agile software development. The idea that no matter what seems to be going wrong, there's a very good chance that if you cut a feedback cycle in half, things will get better. And then when you get used to that, cut it in half again. And when you get used to that, cut it in half again. And eventually, it won't be a problem anymore. Now, I know I'm pretty short on time, so I'm going to take a quick look at my list here and see if there's anything that I should add that I can do in 3 minutes. Yes? I'm going to do this in 3 minutes, and I have 3 clocks in front of me, which will force me to do it in only 3 minutes. This is a technique that I use. Sure, why not? All right. This is a technique that I use to help explore products with customers. Now, one of the biggest problems that I've seen that came out of applying Scrum ideas and XP ideas over the last 10 years has been this difficulty prioritizing. It's as though we're asking business people to make impossible choices about which thing to build next. And part of the problem, I think, is that we still are not really all that good at making our features small enough so that priority decisions can be made more easily. And so often we end up in these situations where we're asking businesses to choose among 3 things, all of which they absolutely have to have. And I know we think, oh, you keep saying you have to have it, but you don't really have to have it. No, they really have to have it. In order to be a cohesive, useful product, we need to deliver these 3 things. The problem is that we don't necessarily have to build all 3 of those things as perfectly as we possibly can. Now, again, quality, meaning does it work correctly, needs to be high, generally speaking. But maybe it doesn't need all the extra little bits and bells and whistles and sparkly parts that make it the differentiator. And so that's where I find that using these categories of cars can be helpful. So we talk about these as metaphors for the levels of, let's say, levels of niceness of features. So we have the Toyota, which until recently was pretty well the safe, functional, guaranteed to get you from point A to point B, maybe doesn't have a lot of very cool features, but has sort of the basic features that anyone who owns a car expects to have. Then you have the Lexus. right? The Lexus has some luxury items that people generally know that they want, right? There's the seat warmers. Where I live, you definitely need seat warmers in the winter. So the seat warmer under every seat, and the plug-in for your MP3 player, and the satellite navigation with the very cool rear view camera, all that stuff might be, there are things that you know that you want, and the only reason you buy a Toyota is because you can't afford a Lexus. And then there's the Bentley, which includes things that you don't even realize you want. The kinds of things that once you experience them, you immediately say, how did I ever live without this stuff? And then at the bottom we have our friend the Lada. If you can't afford a Toyota, and you're willing to risk getting maybe from point A to point B, then you buy the Lada. We can describe features this way. So the Toyota is the basic functional version of a feature. It passes all its tests. It does the absolute least necessary in order to be able to achieve a goal. So instead of this nice administrative user interface, you might have to write some scripts and pay a programmer to do it. Or instead of having this workflow done for you, the steps are all there, and the workflow is something that you enforce yourself. And then the Lexus is where the Lexus version of a feature is where you add all the extra parts that you know your customers want. And if you try to go for a Bentley version of the feature, that's where you're trying to do what, for example, companies like Apple try to do, and to sell you the thing you didn't know you needed. Now, sometimes if our budget is really, 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 really low, then we say, well, okay, if I have to actually program some things in order to make this work, if I have to hire a programmer to do this work for me, or if I have, maybe there's a couple of places where the connection isn't quite perfect, I can live with it. We only build a lot of features if we absolutely have to. But there's a very simple way now of negotiating the level of a feature. Most companies have problems prioritizing because they think they have to build the Lexus version of everything and the Bentley version of some things. And what ends up happening is over the length of the project, we end up beating on each other, and at the end, we deliver mostly Ladas with the occasional Toyota. There's a really simple way that we can solve this problem, or at least make this problem a little bit better. And this would be much more dramatic if I could actually see the slide that I want. What if for every feature in the system we simply built the Toyotas first? What if we built the Toyota version of pretty much every feature up to the first major product release, and then got that in the hands of some users who can then tell us which Lexus features they want? Because some of us want the seat warmers, and some of us want the rear view camera, and some of us want some other feature that's a luxury feature that we want. But I don't necessarily know which Lexus features you want until you try driving the Toyota. So if you don't know how to help, if you're having problems with this priority and I can't choose this over that, try building the Toyota first. Get that in their hands, and then you'd be surprised that they probably want different Lexus features than you thought they wanted. And that way you can avoid building what they don't want and spend your time building what they do want. And since I'm out of time, and we're being very strict here, thanks very much for your time.